Hello everyone, welcome back. So today we're going to do a little bit of math. And let's begin with Chapter 9, Geometric Figures. So the first thing we're going to talk about is what are supplementary, complementary lines and the congruent verticals, and vertical angles and parallel lines. Supplementary lines. Supplementary lines are lines that add up to 180 degrees. So we know that 105 plus 75 would give us 180. Complementary lines. Complementary lines are lines that add up to 90 degrees, also known as a right triangle. So we have to add 30 plus 30, which would give us 90 degrees. Vertical angles. Vertical angles are angles that line up, that intersect and meet at the vertex. So 42 and 42 here are congruent to each other. Parallel lines are two lines that go side by side each other, but they never intersect. So, and this problem, I'm going to need this. That's just going to make me hella confused. So here's 1. Here's 2. 3. Jerry, what are you doing? Stop. So we know that in this figure, we are asked to find the measurements of angle 1 through 12. So we know that line 1 and line 2 are parallel to each other. We are given 63 degrees and 61 degrees. So to find angle number 1, we know that it's congruent to angle number 5, which would give us 56 degrees. To find angle number 2, we know that it's a vertical angle, which is supplementary to 63 degrees. Angle number 3 is supplementary to angle number 4, which they're similar, which is 61 degrees. Moving on to number 6, since it's on a supplementary line, we would do 180 minus 61. So we would get 119. Angle number 6 and angle number 10 are similar angles. So that would be 119 as well. Angle number 9 is congruent to an angle number 4, making it 61 degrees as well. To get angle number 7, we would add 63 plus 61, which would give us 124. Subtract 124 from 180, giving us 56 degrees. Angle number 8, we would do 180 minus 56, which would give us 124. Angle number 11 is congruent to angle number 8, giving us 124. Angle number 12 is similar to angle number 7, giving us 56 degrees. Here we see a chart that there was no complementary lines. There were similar and supplementary. Angle number 9 and 61 degrees are similar. Angle 1 and 5 are similar. 2 and 63 are similar. 6 and 10 are similar. 3 and 4 are similar. 7 and 12 are similar. 8, 11 are similar. The supplementary lines are 9 and 10, opposite sides. 11 and 12, 1, 2, and 3 that add up to 180, 2, 3, and 5, 8, 12, 7, 11, 7 and 8, 6 and 9, 2, 1, and 4. In question number 2, we are asked to find the angles 1 through 8. So to find angle number 1, we will do 26 plus 74 because these are angles that were already given to us from the beginning. So that gives us 100. From 100, we subtract 180, giving us 80 degrees. So we know that angle 1 is 80 degrees. Angle number 3 is also interior angles. They're congruent. So angle number 3, angle 5, and angle 8 will all have 80 degrees. So to get angle number 2, we would add angle number 2. We do 180 minus 80 from this and get 100 degrees. So angle 7 is similar to angle 2, which would give us 100 degrees. So right here, to get angle number 6, we know that we have to find the measurement of angle number 6. So to find the measurement of angle number 6, we know that it's the same measurement as C, because B and C run through the same line, A and C are in the same line, and R and Q are the same line. So it's congruent to each other. So it'd be 74. Point B and point 4 are congruent to each other. But if you didn't know, you could do 174 minus 80 degrees, which would give us 26 degrees. Here's a chart of how there was no complementary line, the supplementary lines, and similar lines. So the supplementary lines are angle 7 and angle 8, 2 and 3, 3 and 4, 5, 4 and 6, 6 and 8, point 1, B and C. So it makes a triangle. The similars are 2 and 3, angle 4 and point B, angle 6 and point C, angles 1, 5, 3, and 8 were similar, which is the same. So in question number 3, we are asked to find the concave 8-sided polygon. So our formula we're going to use are n minus 2 times 180. We know that n means the number of sides. So we would do 8 minus 2 times 180, giving us 1,080. So then our next step is to figure out how many y's there are. We add up all the y's and get 54y. We divide 54y by 1,080, and y would give us 20. So to find angles 7, 3, and 12, all we have to do is substitute that y for that 20. So here we see 12 times 20 equals 240, 3 times 20 equals 60, and 7 times 20 would give us 140. In question number 4, we are asked to find the sides of the nonagon. The first one we're going to look are interior angles. What are interior angles? The interior angles are the angles that are found inside the shape. We will use the formula n minus 2 times 180 divided by n, where n equals the number of sides of the polygon. We know since it's a nonagon, it is a 9-sided figure. So it's a 9 minus 2 times 180 divided by 9, which would give us 140. So the interior angles would equal 140. So what are exterior angles? Exterior angles are angles that are found outside the shape. So the formula we would use would be 360 divided by n. 360 because that's what the whole shape is equal to. So we would do 360 divided by 9, which would give us 40. Therefore, the exterior angle would be 40 degrees. What are central angles? Central angles are angles that are found in the center, as the arrow is pointing. Therefore, we will find that 360 divided by n, which was 9, would give us 40, the same thing as the exterior angles. Question number 4. Tetrahedron. What is a tetrahedron? A tetrahedron is a triangle that has 4 equilateral triangles, and this is a tetrahedron inside a cube. We know that lines D, E, H, and G are in one solid color, which is a tetrahedron, and the purple shows the cube. A tetrahedron has 4 triangle faces, 4 vertex corners, and straight edges. So here are the 4 triangle faces. 1, 2, 3, 4. The 4 vertex corners, which is where the black dots are at. 1, 2, 3, 4. And 6 straight edges. 1, 2, 3, 4, 5, 6. An octahedron. An octahedron has 12 edges, 6 vertices, and 8 faces, as one can see. So the 6 vertices is the same points, 1, 2, 3, 4, 5, 6. 12 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 8 faces, 1, 2, 3, 4, 5, 6, 7, 8. And that is an octahedron. An isohedron has 12 equilateral triangles, 12 vertices, and 30 edges. Thank you so much, class, for watching this Chapter 9 Equilateral Geometric Figures.